Measures of variability. What is measures of variability? This refers to the spread of values about the mean. Spread of values. Yes, spread of values, as in dispersion. Let's dig deeper into what are these all about. Measures of variability of ungrouped data. The same as the measures of central tendency, we do have the ungrouped data and group data. So first, we will have to talk about the measures of variability for ungrouped data. For measures of variability of ungrouped data, we have the range, mean, the standard deviation, and variance. So let's talk these one by one. The first one is the range. Range is the difference between the highest and the lowest values in the given set of data. This is the first step in making a frequency distribution. Yes, this is the first step. If you could still remember about how we make the frequency distribution, then the first step is the range. So the same as that process, so we still have the formula range equals highest score minus a lowest score. So let's have some example. So find the range of the given set of data 2, 4, 6, 8, and 10. So for our solution, so we have highest score minus lowest score. So what's the highest score in this given set of data? It's 10. Yes, it's 10. And the lowest score is 2. So we have here 10 minus 2 is equal to 8. So as simple as that. Next is the mean deviation. So how is mean deviation computed? So we will know it later. Mean deviation is the dispersion of the data about the average of this data. Average. So as we all know, in the measures of central tendency, that mean is the average. So we are getting the dispersion of this data about the mean. Okay, so we have here the formula of the mean deviation. So we have here the notation MD is equal to these notations here, which is defined below. So MD is the mean deviation, and X is the individual scores, and X bar is the mean, N is the number of scores or the number of observation. And then we have here, this notation is the absolute value of the deviations from the mean. Next, in computing for the mean deviation, let's focus on these steps. Number 1, find the mean of all the scores. I have already a video on the measures of central tendency, so you can visit on how to compute for the mean. Number 2, find the absolute value difference between each score and the mean. And then number 3, find the sum of the difference and divide it by the number of observation. Example, find the mean deviation of the given set of data 2, 4, 6, 8, 10. Solution. For the step 1, we have to find the mean. So we have here X bar is equal to summation of X over our number of values. We have here added all the values and then divided by 5, which is the number of population. So we have here 30 divided by 5, which is equal to 6. So therefore, our mean is 6. For the step 2, to find the deviations from the mean and the absolute deviations from the mean. So we have here X minus X bar, which is scores minus X. So we have here step by step shown in each row. We have 2 minus 6. So 6, if you still remember, this is the value of our mean, which is equal to negative 4. So we have a 4 minus 6 equals negative 2. And 6 minus 6, that's equal to 0. 8 minus 6 equals 2. And 10 minus 6 equals 4. So in the third column, we will get the absolute deviations from the mean. So our negative 4 here, it will become 4. And our negative 2, it will become 2, and so on and so forth. And then in the last row here, we need to get the summation of the absolute deviations from the mean. So that's equal to 12. This is now the step 3, solving for the mean deviation. So the summation that we get from the table, we only have to substitute here, and our N is 5. We have here 12 divided by 5 is equal to 2.4. So that is our mean deviation. If we will show it in a graph, so how does it look like? So shown here in the graph is the absolute difference of every score in the given example. So how does the absolute deviations from the mean looks like in the graph? So our scores here, so we have here the scores, and here is our student. So the deviations from the mean is illustrated here. So the red arrow here and the red circle is the mean, which is 6. The 8 scores deviates from the mean. So this is already the absolute deviations. 2 minus 6 is -4, and its absolute value is 4. And here the deviation is -2, and its absolute deviation is 2. So here it's 0. So it deviates 2 upward, and also it deviates a 4 upward for the last student. So this is how the absolute deviations look like. On the graph, we can also compute this, get the sum of these values, and then divide it by the number of students here. And then the same, we can get the mean deviation. Next is variance. Variance is a measurement of how far each number in the set of data is from the mean and to every other number from the mean. So, for example, if you want to get a variance of the sample weight of your students, then these are the group of 5 students having their weight 38, 43, 56, 59, 64 kilograms. So the mean here is 52. So in the red line here, we have the mean. Let's see how far each student's from the mean. The first student weighs 38, therefore its deviation from the mean is -14. The second student weighs 43, therefore its deviation from the mean is -9. The third is 4, the fourth is 7, and the fifth is 12. We need to get the positive values, therefore we have to square each deviations from the mean. The squared of -14 is 196. The squared of -9 is 81. Squared of 4 is 16. Squared of 7 is 49. Squared of 12 is 144. Get the sum over n. The sum of these values is equal to 436. And let's divide it by the number of students, and the value is equal to 87.2. That is the variance. In table, so we have here the formula of our variance. So this is the symbol for our variance. Variance is equal to summation of the square deviations from the mean over n. We have here in our table the weights, and then the deviations from the mean, and the square deviations from the mean. So that is the same. So let us use our mean to subtract each of the weights to get the deviations from the mean. So we have here -14, -9, 4, 7, and 12. So squared, so we have here 196, 81, 16, 49, and 144. The same as what we have solved on the last pages. And then get the summation of the square deviations from the mean, which is equal to 436. So substituting into the formula, so we have here 436 divided by 5, and we get the same value of our variance. Next to that is a standard deviation. Standard deviation is simply the square root of the variance. So since that we already have the step-by-step solution of our variance, then we will jump into how standard deviation is being solved, starting from our value of our variance. So we have here the computation of our variance. So variance equals the summation of squared deviations from the mean over n. and we get this value 87.2. So we only have to use the formula square root of the variance is equal to square root of summation of the square deviations from the mean over n. So since that we already have the value of our variance, so we don't need to have the step-by-step form of the computation. We can just simply substitute the value of our variance, which is 87.2. So we get the square root of that, and that's equal to 9.34. So that is now our standard deviation. What is the implication of the values of the measures of variability, especially the standard deviations and variance, since that these two measures of variability are most used in a lot of research? So take a look at this graph here. So we have two graphs. Therefore, we have two sets of data. So we have here the blue graph and the red one. So these are example of samples from two populations with the same mean but different standard deviations. So what does it mean by a smaller standard deviation? So red here, red population has the mean value of 100 and SD, or the standard deviation of 10, and blue population has mean 100 and SD of 50. So as we look at the blue population, so its standard deviation is 50. So look at the spread of values. It is spread towards its end. And look at the red population. So it is much clustered at the center, nearer to the mean. So if we get the reliability of this result, so the red population is more reliable than the blue ones. Another example, let us say that a doctor studies the effectiveness of new discovered medicine for flu. Let us say that medicine A and medicine B are given to a sample of people to test its effectiveness. So as a result, the ST of medicine A is 5 and the ST of medicine B is 10. So the graph must show like this for medicine A, and for medicine B is like this. In the graph of the medicine A, since that SD is 5, the result are more closer to the mean. Therefore, and this medicine is reliable than that of the medicine B. Therefore, doctors might conclude that this medicine A is more effective than medicine B. So as a summary, a large standard deviation indicates that there is a lot of variance in the observed data around the mean. This indicates that the data observed is quite spread out, while a small or low standard deviation would indicate instead that much of the data observed is clustered tightly around the mean. Smaller standard deviation and variance is better than bigger result of standard deviation and variance. If you find this video helpful, please click the subscribe button and hit the notification bell to keep updated for my new uploads. Thanks for watching.